In this video, I'm going to do a little walkthrough on how I've set up Kanata to let me use my full custom keyboard layout using the built-in hardware keyboard on the MacBook here. And this app actually runs on Linux and Windows machines as well. And of course, if you're used to using a hardware custom keyboard, it can be kind of annoying to switch to a laptop and use the built-in keyboard. So this solves that problem, lets you use the same advanced custom keyboard layout that you've got set up on a hardware custom keyboard on the built-in keyboard here, including support for things like home row mods, tap hold, all the subtleties around the timeouts of those, and combos, and way more even than I need on my layout here as well. But if you're new to the idea of custom keyboards, this is also a fantastic way to actually get started for free using the hardware you've already got, so you haven't got to commit to obviously buying a hardware custom keyboard. So if you're new here, I'm Ben Valak and I'm a software developer, and I use this channel to use my developer mindset to explore optimizing all kinds of day-to-day workflows and processes, not just working with computers. And recently I've made a commitment to move away from taking sponsors and freebies on this channel. So more than ever, your membership is super appreciated. It's been amazing seeing how many of you are coming on board since I made this change in direction on the channel. So thank you ever so much for that. So let's get stuck in and we'll look at how I've got this up and running. So the main application is called Kanata, and this actually uses the Carabiner driver kit, which is the same kind of behind the scenes stuff that Carabiner Elements uses. Now, Carabiner Elements is obviously a very easy way of getting started and remapping your keys on your Mac here. But behind the scenes, there's way more power available, and the Kanata application actually takes advantage of all of that and lets you set it all up just using a single config file. So in some sense, it's kind of a bit easier than trying to work out the Carabiner Elements system. So let's get stuck in. So the process is you have to first of all install the Carabiner driver kit. Now this gets a little bit confusing because there are so many different versions and they support different versions of macOS. So version 5, obviously the latest one, doesn't support Monterey, which is what I'm running here. So for me, I have to go back and work out the version that supports Monterey, and that's version 3.2 basically. So after version 4, it drops support for the old macOS versions. Now this obviously gets a little bit more complicated as well because Kanata itself uses the different versions. So the latest version of Kanata 1.8 uses version 5 of the driver. So that means I have to go back and use 1.7 of Kanata itself as well. So with all of this, just the most important thing is to make sure you're looking at the instructions for the version that you're using and make sure you're using the right version for your operating system. And then it's a question of downloading the right binary for your platform. So they've got loads of different versions here, obviously for the different CPU types as well. So this is the one I'm using here. I've downloaded that, and then you just run it in the terminal with one of these commands, with both of these commands. You have to activate the driver first. So once you've done that, and again, check the instructions on the right version because the activate command differs between the versions on those. So activate the Carabiner driver, and then you run Kanata itself, and you just leave it running in a terminal window, and that's what I've done here. I think there are ways of getting it to run in the background, but I'm quite happy just letting it run. I've got the debug mode on, so you can kind of see all the output, which is quite fun. So then you need a config file, and you reference that using this part of the command that you run when you actually run it. So set up the config file on your system and then launch Kanata with this, and then obviously you can quit and reload. Quitting Kanata is interesting. So when you first run it, it tells you how to do it. It's basically holding down Control, Space, and Escape. That will quit it. So if you get in a pickle and you launch it with a config that doesn't let you type, you can escape, and that's how you do it. Obviously you can close the terminal window as well. So let's look at my config here. So the basic kind of format syntax here that Kanata config uses, it uses these brackets, sort of definition blocks, and then the first word is the reference to the Kanata thing that you're setting up. So this first block, and this is required in the start of the config file, is where you actually just map out the hardware keys on your laptop, basically on your hardware keyboard. So we're using rows and columns here just to make it easier to understand when we're looking and working with the config, but actually as far as Kanata is concerned, all that's happening is it's just seeing a long string of different keys in that order. And when we come to remap those later, it just uses the same position in that order of different keys. So that's all that's going on, but we can add line breaks and spaces to make it easier for us to work with. So if I just jump down a second, we're going to look at the layer definitions. So we've got the def layer bits here. And I've got one of these blocks for each of the layers that I'm using in my custom layout. Obviously layers with custom layouts is sort of how you know, one of the best features about them, and obviously toggling between the layers using a tap hold system is kind of the main defining ability of a firmware based custom keyboard. So we've got that ability now using this software approach with the built-in hardware, which is amazing. So we can see this is the same set of key positions with the remapped keys in this bit of config. So these match up exactly, and you'll get an error if you've got a different number of items in here than you have in this first block here. So you have to make sure there's the same number. You get an error if not. Some of the keys are a little bit weird names. So this one on the UK Mac keyboard to the left of the one key is actually called the international / key. You have to obviously find out the proper way of writing that. A lot of those are documented in the Kanata documentation, so you can find them there. And then these ones are obviously all pretty self-explanatory. This is the kind of format they use for the modifiers, just L or R for left or right, and then Alt, Met, and Control, CTL space here, and so on. So once you've mapped that out, that's then obviously ready for the rest of the config to take over and say, what do you actually want those keys to do instead? So the next thing you want to set up is the def var section here, and this is just a couple of variables. Now obviously we're working with the tap holds for mods, so I'm actually not using home row mods. My mods are on the top row. I'm using the home row tap holds for switching layers. It's the exact same process, and we use the hold time to define how that works. So when you're setting up tap holds, the idea is you don't want those to be triggered through normal typing. And obviously with normal typing, you roll from key to key, there is an overlap. So in theory, the potential for triggering the held version of the key while you're normally typing is there, but you obviously want to make sure that doesn't happen. So you have a fairly long timeout, so 200 milliseconds here. That makes sure that all your rolling is done within that timeout, and you're not going to trigger the hold version of that. Now there was an interesting tip that I've just left in here that came from the default setup, and that it suggested to use a slower timeout for your slower fingers, so the ring finger and the pinky finger. This is a brilliant idea. You're more likely to dwell with these fingers when you're rolling through normal typing, so it makes sense to increase the timeout on those, and that was a brilliant tip. So we've defined hold time and hold time slow as two variables that we can use later in the config to reference those timeout millisecond values. And then we get into the aliases, and this is where it gets really fun. So again, it's this same idea that inside the brackets you're referencing a Kanata action. So this first word after the opening bracket is the built-in action that you're configuring, and the word to the left of it is our custom name for this use of that action. So I'm defining an alias with my name here called meh, and it's the multi action, and that lets you then specify a bunch of modifiers that will fire all at once. So I've defined the meh key here basically as an alias. That alias is then used either in the layouts themselves or in the definitions of other aliases. So that's, you can see here with the @ symbol, we've got our meh alias referenced in this tmeh alias. So this is actually how we set up the tap hold. So I'm setting up a tap hold, I'm calling it tmeh. So we obviously tell Kanata this is what we're doing with the tap hold, and there are loads of different versions of this. If you want to get really stuck into this, there's different flavors in the same way you have with ZMK. There's different ways that the timeouts are used in terms of what happens when keys are interrupted or released at different timeouts. The standard one, tap hold with a 200 millisecond, I feel for me works absolutely fine. It stops the layer versions triggering when you're normally typing, or the mods, and it works really well. You can see here with the dollars, we've got the references to the variables. So we've got the tap time and the hold time from our variable definitions above. And then we've got two, so the tap hold takes two properties here for it. So the first one is the tap, and that's just a space in this case. And the second one in this case is the other alias, which is the meh key. So when it's held down, that's what happens. So you can kind of just keep going down here and see the rest of these are layer toggles. So this is where I'm actually creating the alias, again using my own naming conventions here. So I've just got the L prefix for the layers, so I know what those are when I see them in the layout. And then we've got layer toggle, which is us saying this is, this is what this is. That's the Kanata config that we're using. And then here is the name of the layer. Again, this is what I've called my layers: command sys1, sys2, and num. And if we go down, we can see where I've named those. So these are the def layer blocks, and you get the, obviously def layer is the Kanata instruction, and then the next word is your own name for that layer. So I've just called those, and then you can reference those in the aliases. So we've got the mechanisms to switch layers here. This doesn't deal with which key or anything. This is just purely the configuration for these mechanisms at this stage, and we're giving them all names so that we can use them later. Now I'm setting up the actual tap holds for most of my home row keys and my top row keys that behave with this tap hold behavior. So all of these keys are set up as aliases, and I've just literally just used the letter name as the name of the alias for those, so it's nice and easy to see what's going on in those later. So if we look at this first one, the S, we can see it's a tap hold that outputs S when you tap it, and then it uses the layer switch to the command layer on hold. So you can see it's got the @ symbol. That means it's referencing this alias, sorry, the next one, that one, the command, and then when it's held down, it means it's going to switch the layout into that layer. That's basically how you set up all of that. You've got the mod version here, so this is L, my top row, ring finger, L on tap, control on hold. So that's a standard home row mod on my top row in my case, but so no reference to another alias in this one. It's just simply the letter on tap and the mod on hold. Nice and straightforward, and that's the same with all of these here. I've got a couple of other slightly more interesting ones that aren't letter keys here, so they'll do, well, this is the forward delete and the home on hold. So home and end I actually have as hold versions of existing keys, and this one here is for on another layout. This is on my command layout. I've got some other controls for doing things like switching tabs or going backwards and forwards in browser history. I've set all those up, so this is just one of those, and one of those keys will then do the end function when you hold it down. So just a couple of useful extensions to that. I'll look more at my actual layout and some of the decisions I've made in another video, but that's just what I've got going on there. Okay, so now it gets a little bit more interesting. We're looking at chords. So this is a brilliant way of using a small layout without having to use layers. So for me, on my current layout, I've replaced some of the home row keys with my thumb keys, and this means I've displaced some keys, but I still want fast access to those keys on the main layer without going into another layer where, of course, that timeout becomes a problem. So if you want to be able to just sort of almost roll into a key that you haven't got, you can use chords, which is where you just hit two keys at almost exactly the same time, and you work with a very small timeout to make that possible so that you don't trigger that through the rolling of normal typing. This is like the opposite effect of a tap hold. So you have to trigger it within a tiny timeout so that you don't trigger the combo through normal typing. So basically we've got the RT and S keys, and these are part of one combo. Now you can see this Z dash, this is my name for my configuration of this combo, and that's actually set up down here where we see the Z dash, my name of it again there in the def chords Kanata config section. So I've defined one of these chord setups. I've called it Z dash, and the timeout is 15 milliseconds. So I have to hit both those keys within 15 milliseconds for it to trigger. It doesn't tend to happen that I type that fast that I trigger that through a roll. Is obviously the faster you type, the faster you have to be able to hit your chords to get this to work. It's not, you can't do chords with all your fingers on all your keys. You have to kind of, they've usually got to be close together to pull this off. So on my left hand home row, I've actually got two different chords. So you can see here the dash and the Z. So my index and middle fingers will give me the Z. My middle finger and ring finger will give me the dash. So I'm reusing the middle finger for two separate chords. This is why this is set up in the same configuration. So we first of all, and this is quite a nice little syntax when you see what they've done here, you define the letters, and then so you have one line basically for each setup of this whole chord. So either the keys pressed by themselves, it needs to know what happens in that situation, and then when the keys are pressed together, it needs to know what happens in that situation. So we've got the RT and S keys, and this is obviously using my normal tap hold aliases for the RT and S. So A single tap, when it's not in conjunction with another key, will use my normal tap hold, R on tap, and whatever layer switch I've got set up in that alias. And then we then define what happens when you hit both of them at the same time. So in this case, we can see the R and the T are the ones we're talking about. Hitting those together will give me the dash. If I hit T and S, I'll get the Z. So that's actually just how you set up chords and combos. And this one's interesting because it reuses the T key. I've got another one set up down here for my apostrophe, and this is much simpler. This is a single definition with just one combo set up. So it's two keys. It's the H and the A on my right hand. This is what happens when you tap them individually. Just simple tap hold layer switch for the alias that I've set up for H and A. If I hit both of them together, I get the apostrophe, and it's that simple. So where you've got the definition of the chord itself, you can then set that up as an alias that you can then reference. So you obviously want this set up per letter so that you can say to the layout later which one of these is going to use. So you set up an alias for each one of the keys inside that combo. This is kind of quite hard to understand, but if you think that every position on your keyboard needs to kind of reference an alias, and you can't obviously just reference a chord thing by itself because it doesn't know which letter it's actually dealing with, so you have to sort of remap the chords setup into individual keys, and that you do that through aliases. So you can see these are two separate key aliases, but they both reference the same chord config. Let's just jump down and see how we've set that up in the actual layer. So you can see my primary layer here. And this is basically, so it's a slot for each of the keys from the def source layer at the start. The top row is recreating the normal built-in Mac functions, and then the next row is almost, this is the number row, is almost completely, it is completely turned off. So two capital X's disables those keys. That's just completely gone. The top row here, we can see B is just a normal B, and then I've got my top row mods, the tap hold mods. So these are the aliases where we defined the letter on tap and the mod on hold. And then here we can see the alias for those chords. So it's one for each of the letters in that chord combo setup, the R, the T, and the S. And this is my naming convention for the aliases where I reference those letters from those chords. So you can see that's how you get that into the map itself. It's simpler, I think, in reality than it is to try and understand it in the first case. Hopefully I've managed to explain that. There's huge power there. It's actually a really logical, really nice approach. I like how this is set up. There's a lot of power under the hood, but obviously when you're wading through the instructions, it is quite hard to get your head around initially. So I hope that's kind of just shown basically how you set that up. So it's aliases, it's your def source at the start for your, let's just jump back up here, so def source for the start where you set up the actual keys that you want to remap, a couple of variables, and then if you're using combos, you set those up and then reference those through aliases. And then when you're defining your layers, it's just simply a case of making as many of these def layer blocks as you like, giving them your own name. And as long as you set up the layer switch in the alias using the same naming convention, you can set the board up to switch between those layers. And most of my sort of secondary layers haven't got that much on actually. My number layer will just give me the sort of numpad style keys on the right hand, and everything else is kind of turned off. And there's a couple of other tricks. I think I'll do another video looking at the current layout and some tips and tricks that I've actually got going on in this current layout. But that's it. It's, you know, all the power you expect from ZMK and QMK style keyboards using built-in hardware keyboards. Absolutely awesome way to get started with custom keyboards, or make it easier to use normal laptop hardware if you're used to using hardware custom keyboards like me as well. So hopefully that's been useful to you. Let me know what you think in the comments, and I'll link to another video on screen here, and I'll see you there.